Mr. Elise, in 4 minutes you can start.
In 4 minutes?
Yes.
Or 3 minutes?
Okay. Now we are online on YouTube.
Okay. All right, let's get started. The first paper by Matthias Luemba and co-authors is on exploratory analysis and visualization of Brazilian forest data. Matthias?
Yes, I'm here.
Yes, can you share your screen then?
Can you see?
Yes.
Good afternoon, everybody. I'm Matthias Emil Luemba. I'm going to present my paper with title Exploratory Analysis and Visualization of Brazilian Forest Data from the Forest Document System of the Brazilian Institute of the Environment. Introduction. Forest's original document, so-called DRF, is compulsory electronic license for transport, trade, and storage of forest products of native origin. DRF control and supplies transport, commercialization, and wood processing that first allows us to processing a link before being considered as finished product. Topic of study: illegal logging and wood extraction. The difficulty in tracking and quantify the wood being harvested from Brazilian forests, because harvesting often does not from a large clearing that can be visualized from a satellite image. These included logging in area with difficult access, wherein the wood is transported by river. Also then, the falsification of documentation regarding word extraction is another critical issue. The high rate of illegal logging, international of several non-governmental organizations of environment protection. Hence, the concern to better understand the functioning of the timber industry from open data and visual and analytics tools. Tracking the wood extraction and other related issues such as wood transportation, claims, and protection of reserve forests and protected areas. A bibliography survey of literature was performed. Computing framework was also constructed from exploratory data analysis and visualization tool. Database flora explored in this study. The Forest Document System of the Brazilian Institute of Environment, DRF IBAM. Two subsets of the DRF system were considered that set governing the Brazilian state, Acre and Rondônia under interval ranging from 2016 to 2018. Result and discard. This figure shows the year-on-year evolution of DOF emission for the Brazil state of Acre and Rondônia, where Rondônia has a much higher number of the DOF insured. This figure shows the comparison of DOF emission destination state of wood products in Brazil market, grouped by years. One can observe that DOF emission destination have been increasing year on year during the period. This table, considering the products report in sow wood, is the one which holds the highest rates the commercialization and the emission of DOF's document in several regions between years 2016 2018. This figure shows annual evolution of the wood transported, highlighting the years 2016-27 in the state of Rondônia. Notice that there was decrease in this volume of wood transportation for 3 consecutive years in different states, except for the state of Rondônia. Evolution of wood transported by region. This figure display the transportation of the wood products organized by region of Brazil between the years 2016-28. From the plot graph, one can check that the main destination of wood products are the north and the southwest and south regions. This figure shows the relation between the value and volume cubic of the transport burden. Finally, this relation of the price to the volume of the transported word is the core discourse from the plot that one can verify that some points holding a large volume of the word were registered at low price, as well as small value of the transported cargo with extremely high price. Conclusion: exploratory data analysis and visualization tools of data from Brazilian DOF system was applied in this work. Two Brazilian states were studied, Rondônia and Acre, over the year of 2016 and 2018. After carefully analyzing the forest data from DOF the database, it was possible to understand the relation among different variables from the full database, as the total amount of the extras, wood, transportation price, destination, among others. The main word shippers and recipients were also studied in this study. Analyzed in this study, including the state with the highest, lowest number of transported wood loading and relation between price and value of the traded wood. Thank you.
All right. Are there any questions? You said the study was over the years 2016 through 18. Are there
Yes.
similar studies also later, the last couple years, like 2019, 2020? Are there similar studies, or are you working on more studies like the ones you presented?
I worked this the year and the 2016 and the 2018.
Okay. Any other questions? All right, then. Let's see. Lucia, should we wait on 5 minutes, or can I just start my talk?
I don't know. I think it's better to go to the next presentation.
All right, so for the next presentation, that is my presentation. I'll share my screen.
Sorry, Elise, I asked to the previous speaker to turn off the sharing screen, please.
Yes.
Okay, thank you.
Lower screen. It says talk. Entire screen, okay. Can you see my screen?
Not yet.
How about now?
Okay.
You can see it? Okay.
Yes.
Um, my talk is on self-energy Feynman diagrams with 4 loops and 11 internal lines with Fukuko Yuasa. So after an introduction, I'll introduce the methods for the computation and then give some results and conclusions. For the motivation for calculating these loop integrals involve problems for which the standard model of particle physics does not provide an adequate explanation. We need accurate theoretical predictions in view of improvements in the technology of high-energy physics experiments. And these will give rise to higher-order corrections for the cross-section, for particle interactions. And then the loop integrals come in through the Feynman diagram approach. There are symbolic packages to do these computations. We will use PySecDec for comparisons of our results. So we resort to numerical approaches for the multivariate integration. Then here is an expression for a loop integral in general. The first line expresses the integral over the unit cube in n dimensions, and then that reduces to an integral over an n-1 dimensional simplex. The c and the d under the integral are polynomials, and the nu is the space-time dimension. That is that depends on a parameter epsilon. Epsilon will appear in the asymptotic expansions for the integrals as epsilon goes to 0. Then here are the diagrams for which we obtained results. They're called M61, M62, M63, and BH. The asymptotic expansion of the integral as a function of epsilon is in powers of epsilon, epsilon to the k. For the first 3 diagrams, the massless cases, the leading term is in 1 over epsilon. For the BH diagram, the expansion is finite, and the massive cases are also finite. For the methods, non-adaptive methods, we first have QMC quasi-Monte Carlo lattice rules that evaluate the function, the integrand, over a fixed grid. Embedded lattice rules we use with m equals 2. If Q is a lattice rule, then Qm is composed of m to the d scaled copies of Q applied to the m to the d subcubes. The generators for the lattice rules to generate the grid are pre-computed. Then as the second non-adaptive method, we have the double exponential method, DE, which does a transformation in each direction that transforms the integral range to an infinite range, and then applies the trapezoidal rule for the approximation. For the adaptive methods, we use automatic integration, where the user specifies a target accuracy, and the computation continues until the estimated error falls below the tolerated error. The adaptive methods, the adaptive algorithm, successively selects the highest error region and to subdivide. We use our parallel adaptive package, parent, that is layered over MPI, the message passing interface, for computation on a cluster. Transformations and extrapolation. We use transformations called the sin M transformation by CD to smoothen singularities in the integrand function. Extrapolation is used to calculate limits numerically as epsilon goes to 0, and we use nonlinear extrapolation by the epsilon algorithm. For the methods, we have MPI, we have DE, double exponential, with MPI, so parallelized. The CD6 transformation, also parallelized with OpenMP, that is for multi-threading. Then this is followed by 2 lattice rules with a CD6 transformation, parallelized, calculated on a GPU. So the lattice rules have, the first one has 400 million points, and the second one 5 to the 13 points. Then we have CD6 embedded versions of the aforementioned lattice rules. And then for comparison of the results, there is PySecDec. All right, so for the results, we can see that the approximations, especially of the embedded rules, are accurate to about 7 digits. Also, DE is accurate. We get estimated errors from the embedded lattice rules and from PySecDec. So the accuracies compare favorably, and our times are much shorter than those of PySecDec. So the Quadro GPU is a Volta GPU. And then for the code, we use a C host program and a CUDA kernel. All right, similar results are given here. The previous one was for the M61 massive case. Then M62, we have similar results. So also the times behave similarly, and the accuracies compare favorably. Same thing for M63. The error estimate for the lower point embedded lattice rule is higher than the error estimate for the 5 to the 13 embedded rule, but they're all just as accurate. And then similarly for BH, right, and here we have an example of an extrapolation. So in the second column of this table, we see we see a sequence of integration results. The sequence is calculated as epsilon gets smaller. It's a geometric sequence of epsilon. The error estimates are in the order of 10 to the minus 3 to 10 to the minus 2. And the times in seconds are very good. Then in the last column, we have the extrapolated results. So you can see that the accuracy gets better. The exact result is 10 times zeta 5, which is given up here too. So we have about 4 digits. And then here is the same example, but done with the adaptive method. So the times are larger, but then, and there's 2 extrapolations that are given in the last 2 columns. And especially, yeah, the accuracy is better than with the lattice rules. So in conclusion, we used exclusively numerical techniques and found good agreement between the different tools for the 4 diagrams. And also with respect to the accuracy, our results compare favorably to PySecDec, but they are much more efficient for these types of integrals. All right, that's the end of my talk. Were there any questions? All right. All right, then I will stop sharing my screen. Or did I already stop sharing?
Not yet. We see your screen. Okay. Now.
Yeah. Okay. So shall we go on with the next speaker? I started early, and then
Yes.
so we're still early. Okay. So the next speaker is Dora Ben Khalifa, and co-authored by Mathieu Martel. And that is on a study of the floating point tuning behavior on the n-body problem.
Yes, thank you. Are you hearing me? Yes?
Yeah.
Okay. So hi everyone. So today I will present you our work entitled A Study of the Floating Point Tuning Behavior on the n-body problem by myself, Dora Ben Khalifa, and Mathieu Martel from the University of Perpignan in France. To start, so developers are likely the tendency to use higher precision. For example, the binary 64 and binary 128 in the IEEE 754 format, which is more accurate and robust, but on the other hand, there is a higher execution of time, the increased memory traffic, and a large or huge energy consumption. So the challenge is to use no more precision than needed by the users in order to have a best compromise between accuracy and performance, and which gives the definition of precision tuning. So precision tuning consists of lowering a computational kernel's precision up to user accuracy requirements. And the goal of this work is that we have implemented a tool that assists precision tuning, and the tool is called POP. So POP, short for Precision Optimizer, as I have said, is a static tool for precision tuning, which relies on a semantical modeling of the propagation of numerical errors. So if we can see here, so if we have a number x, so our reasoning is on the unit in the first place of a number x, the number of significant bits of a number, which is all this green, kernel. So we have here the NSB, and the unit in the last place of a number, which can be computed by the UFP of x minus the NSB of x plus 1. So in fact, our originality is that we generate an integral linear problem from the program source, which can be solved by a classical LP solver. We use the GLPK in polynomial time. And the second originality of our work is that we propose, or we go further to propose, an optimization of this ILP formulation by using the policy iteration technique. So for further information about the technique embodied in POP, we refer the audience to have a closer look on our paper, Fast and Efficient Bit-Level Precision Tuning. However, the main focus of this article, or this presentation, is to evaluate the performance of POP on the N-body problem, so which is a code of approximately 400 lines of code. So our goal is to model the simulation of a dynamical system describing the orbits of planets which interact with each other gravitationally. So we have the Jupiter, Saturn, Uranus, Neptune, and the Sun, which position is fixed. So to analyze this program and even other programs, POP proceeds by 3 major steps. In the first step, POP will take a program, for example, the N-body program, annotated with the precision needed by the user. After that, POP parses the program and generates the equivalent syntactic tree before performing a range analysis on all the program variable values. So let's take an example, which is a code snippet of our N-body problem. So here, as you can see, this is the input of our tool POP. We have assignments, operations such as product, so the square root, we have the while loop, etc. And as you can see on lines 22 and 23, we have the require NSB, which is the statement that informs the users that POP or that the users wants, for example, 11 bits on variable X Jupiter, and similarly for variable Saturn. So after this step, POP will generate, as you can see on the right-hand side here, will generate the same program, but with different control points at each node of the syntactic tree. We move now to the second step, which is the key step of our analysis, in which POP will formulate the problem as an ILP, which will be solved with GLPK problem in order to find the new optimized format for our program. So as we have said, we will reason on the unit in the first place of the numbers, which are known at the constant generation time, and on the NSB, or the number of significant bits of the numbers. So we need to say that in this ILP formulation, we were pessimistic on the way we propagate the carry bit functions, which means that if we take a sample addition, as you can see here in the picture, So we assume that one carry bit is added even in the cases where we have not to add this carry bit. So if we take now one line of the n-body program, which is here given in green, for only this line, purple generates all these sets of constraints. Here we have, I think, 17 constraints generated for this line. So the first two constraints, for example, are for the addition. The other second constraints are for the multiplication, etc. And as you can see here, the constraints of the XC function are the constraints for the carry bit function, which are over-approximated to 1. So we need to say that these constraints are generated for all the program and not only for this line, but for the pop accepts the if, the loops, the for, the while, arrays, SQRT, the sign function, cos function, etc. And in terms of complexity, we have a linear number of constraints and variables in the size of analyzed program. So after analyzing this line with pop, we found, as you can see here, the new precisions given by our tool, which are given here in blue. For example, here for the variable distance, we have 44 bits needed for this variable by respecting the 11 bits so given by the user. And we need to say that these precisions are given at bit level. And if you want, for example, translate them in the IEEE 754 format, we only need to approximate it to the upper number, which corresponds to an IEEE 754 format. So for the third step is, in fact, we will use the policy iteration technique in order to optimize the first method. So here what we have done is to be less pessimistic on the carry bit propagation, because adding one bit in the former method will be very costly, especially if we have large programs. So we propose to make some tests. So we take the numbers, and if, for example, the ULP of a number, of the error of a number is higher than the UFP of a number, then we know that the two numbers are not aligned, and there is no case to add a carry bit in this case. Otherwise, as you can see here, if the two errors overlap, in this case, we see that we can add a carry bit in this example. So this system, or this test is equivalent mathematically to this new formula of the carry bit function. And as you can see here, we have a constraint with min-max operators, and then the program does not remain any longer linear. So for this purpose, we will use the policy iteration technique, which is used to solve the nonlinear fixed point equations. So to be brief, we have adapted the policy iteration technique to the precision tuning problem, because we have constraints of the form f of x is less or equal than x, with f is a map, big P is the set of policies, and n and f of p is a policy map associated to p. So the minimization problem that you are interested to is to minimize the sum of the NSB and the NSB of the errors, such that this equality is always verified. So after applying the policy iteration technique, and if we take the same line that we have already analyzed, we will generate another set of constraints, as you can see here, the set C2. And this set of constraints, in fact, will be added to the former set of constraints, C1, but the only difference is that we activate this C function instead of its over-approximation in the ILP formulation. And the problem will be solved in a few seconds. So as a result, we find the new precisions or more precise data types for each variable of this line and for all the program, as you can see here in blue. And in total, if here we show the tuned n-body program, so with the policy iteration technique, we found that the total number of bits of the optimized n-body program is more than 4,000 bits, and we have gained more than 300 bits with the policy iteration technique than when we use the ILP formulation with the pessimistic carry bit propagation. So let's move to the experimentation. So here in this table, we seek to measure the distance between the exact position of the bodies of our planetary system and the position that are computed with the NSB given by the users, for example, 11, 18, 24, etc. So what we have done here is we have generated the n-body program where all the computations are done with 500 bits, for example. And in some manner, we have generated the program with the MPFR version of the n-body program with the optimized data types returned by POP. So as you can see here, so these measurements were taken for only one single precision of the planets and are taken after 10 years of simulation. So the results that we show here are really good results. For example, if we saw for the Jupiter planet, we have the measured error is of the order of 10 to the negative fourth power, which respects the user accuracy requirements, for example, for 11 bits, for which the worst error is 2 to the negative power. So, also for the remaining planets, we have desirable results for this experimentation. And for the POP time, as we can see here, POP is able to find the new optimized formats in really few seconds. So it takes here, for example, we have 25 seconds for NSB equal to 11 and does not exceed really this time. So if we generalize this experimentation, yes, so if we generalize this experimentation at each instance of simulation, not for only a single position. So as you can see here, we have the error is controlled at each instance or at each iteration of the simulation. Here we present the results for the Jupiter planet, and each curve is for a given NSB. Also, the measured distance is also controlled for the Saturn planet, for the Uranus planet, and for the Neptune planet. So, to sum up, we have presented a new approach for precision tuning with two variants of program methods. One is the pure ILP with an over-approximation of the carry bit function. The second one is the policy iteration technique for more precise carry bit function. So here we have evaluated, in this paper, we have evaluated POP on the n-body problem. So what we can be some limitations that we can tackle is the size of the problem that the solver can accept. Many future directions are possible. For example, we can reduce the number of variables by assigning the same precision to the whole piece of code. This technique is also adaptable for the GNNs and for synthesizing codes for the fixed point arithmetic. So for more information about the POP tool and the technique embodied inside, we refer the audience to have a closer look on our previous paper. And I thank you all for your attention. Yes.
Miss Elas? Can you hear? You have the microphone off.
Sorry about that. Yeah, I was wondering, the question was, how is your package available?
The tool?
Yeah.
So for now, it's the tool is not available on GitHub, but it's proprietary. But in the next time, we will make it available online. The license is proprietary for now.
Okay. Any other questions? All right, then we go to the next speaker. So that is Yushun Lee and Hiroshi Fujiwara on multiple precision arithmetic of Biot-Savart integrals for reconnections of vortex filament.
Yes. May I share the screen?
Yes.
Okay. So can you see the screen and hear my voice clearly?
I can see you. Yeah.
Okay.
Yes and yes.
Okay. So I will start my talk today, and my title is about the multiple precision arithmetic of the Biot-Savart integrals for the reconnection of the vortex filament. And this research is cooperate with Professor Hiroshi Fujiwara in the Kyoto University. So let's start today's talk. So first is the introduction. So first, what is a vortex reconnection? So I will show the video about this kind of phenomenon. So here is a swirling floor here, and you can see that in the part of the of this flow, and they touch to each other, then separate to two parts. So this phenomenon we call the vortex reconnection. So you can see there is a flow here and separate to two rings. So in this research, we imaged this kind of vortex as a thin line called the vortex filament. So this vortex filament we call this kind of thin line we call the vortex filament, and gamma will be the rotation of this vortex filament, and this is the Furness framework of this vortex filament. So next is how do we take a velocity and the evolution to calculate the vortex filament? So we use the Biot-Savart law of this for the incompressible fluid. So let's denote the vortex filament at the time t by c, and c is the vortex filament with the arc length parameter s belonging to an interval I in the real number. Then the self-induced velocity of c is represented by this formula. So this formula we call the vortex filament evolution. So in this formula we can see if we want to calculate the velocity on the self point, and we will have the singularity in here. So I will talk about how our numerical scheme to conquer this singularity. Then this research we focus on the computational reliability of this vortex filament evolution, this kind of phenomenon. So in this paper, we do two case studies. So first one is the closed shape, closed vortex filament. We call the figure of 8 vortex, and the second one is the open curve. We call the tent shape vortex. And due to the time limit, so today this talk I will only focus on the closed one. So in the computation, usually we use a double precision. So, however, in this kind of computation, sometimes the double precision is not enough. So we will want to know about the reliability of this double precision computation is reliable or not. So in the usual double precision, we use a 64-bit, and the decimal digit is about 16 digits. We can calculate it. Then, so in this research, we use two kind of much precise package. First one is the quadratic math provided in the GCC. And it total have 128 bits, and it can take a decimal digit with 34 decimal digits. And another one is the multiple precision package. Is developed by the cooperator author Fujiwara, Professor Fujiwara, and it can take we take the 25 and 56 bits in this research, and it can take about 50 decimal digits. So how do we estimate the rounding errors by the multiple precision arithmetic? So first, we assume that the 50 decimal digits result is the most accurate one. Then we compare it with the double precision and the quadruple precision and calculate the relative errors between them. And we measure the errors at the time and for each time, and get the maximum of the maximum relative errors and at each different time moment. Okay, so next one is I will show about the case study of the bounded case with a figure of 8 vortex filament. So this is the initial shape of the figure of 8 vortex filament. And left-hand side is the initial condition we showed in this slide. And here is the way we do a discretization. So we discretize the theta here by the 2 pi I divided by n. And this figure of 8 vortex filament is proposed by the Kernel and Moffat in 2007. And so in a computation, we can have this kind of phenomenon. So the initial shape is a 8 shape here, and here is almost a parallel, anti-parallel here. And as the time goes, we goes to a 0.32, the two curve is still separate. So this green color means x less than 0, and the purple color means x over 0. And so to a time t to 0.32, the two curves is still separate. And as time goes through t0 to 342, so the curves touch to each others. So we want to, so this is called the vortex recognition. So this disturbance is come from the recognition, and we will take an estimate of the rounding is this kind of phenomenon. So here is the numerical method for the Biot-Savart. It's also proposed by the Kernel and Moffat in 2007. And so at the initial step, the theta I is 2 pi I divided by n. And the delta S is the arc length parameter we we calculate with this formula, and here we use the cutoff method to occur the singularity. And the unit tangent vector is calculated by the Fourier method. And we use the Range-Kudai method for the time stepping. And the gamma is a fixed constant we set as a 4 pi divided by 50. Okay. So next I will show about the video about our numerical result. So first is with this delta t, we set as 2 times to 10 to negative 5. So right hand side is the separation of minimum separation of this curve. So as I rotate this visualization, we can see here this similar I showed before, several slides before, then they will let me enlarge it, and there was two parts will touch to each together. So this we call the vortex-free connection. So next one is if we enlarge the delta t to the 4 times to negative 5. So we can find the disappearance disappearance occurs in a very early stage. So here, so the first one is the delta t. We choose the first video I show is the delta t is 2 times to negative 5 in the under double precision, and the second video is the delta t under the double precision for the 4 times to 10 to negative 5. So both the double precision and the multiple precision has this kind of disappearance. However, the multiple precision, the disappearance is smaller, not smaller than the double precision. It's not so this kind of accumulation of the rounding errors. So both three pictures is at the t equal to the very early stage 0.0024. So next one is about the estimate of the accumulation of the rounding errors. So the left-hand side is a double precision result of this maximum relative errors, and right-hand side is the maximum relative error is each time moment under the quadruple precision. So we can see, so before the reconnection happens, the relative error is very small. It's under the rounding errors level. So also the quadruple precision, and after our estimate reconnection time, so the rounding errors grows up very quickly. The relative error grows up very quickly. So this kind of we can say the disturbance is not under the rounding error levels. So this disturbance may come from the discretization of the physical reconnection phenomenon. So final is the computational time. So if we use the multiple precision package by the ECF library, so under our CPU, we need 2 days to finish the whole computation of the 8,000 point, and the delta t is 2 times to negative 5 for the 20,000 time step. And under the double precision, we only use the less than 30 minutes to finish the computation. So the double precision, okay. So for the larger n, so we can we can use the double precision to calculate this kind of how to compute this kind of numerical computation is enough. So final is the summary of my talk. So first is we present and estimate the strategy of the rounding errors by high accurate arithmetic. And the second one is we estimate the accumulation of the rounding errors by comparing with the multiple precision arithmetic. And final is we verify the reliability of the numerical solution in terms of rounding errors. And this is all about my talk today. Thank you. So if any question, we can discuss it.
All right. Any questions? All right, then let's close this session. So thank you very much, all the speakers, for your interesting presentations. And I think we have 15 minutes until the next session.
Thanks a lot, Elise.
Thank you. Goodbye.
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 Bye-bye. Bye-bye.
Bye-bye.
Lucia?
Yes.
So there was this other speaker that joined us in the beginning.
But I think that he resolved the problem with the organizer.
Oh, he did? Okay. Because
Okay.
he was asking if he could give his talk in this session instead of this morning. And
Yes.
yeah,
Yes,
we do have a little bit of time until.
Yes, but I don't know if he's in this session.
All right, okay.
I don't know if he's.
That's fine. That's fine.
Thank you.
Thank you.
Hello, can I try my screen sharing?
Hello,
Hello.
who are you?
I'm Isaka Kanamori. I'll be giving a talk in the next session.
Okay.
Oh. Okay, what is the next session? Or is that CS
HPC2.
2? Yeah, okay. So it's in the same
Yes.
room.
Yes.
All right, okay.
If you want to try your share screen, you can.
Yeah, go ahead.
Okay. Can I see my screen
Yes. Perfect.
and cursor?
Perfect.
Okay,
Yes.
thank you very much. I'll stop sharing.
Oh, you're welcome.
So is there a different chair for that session?
Yes. The next chair is Rafael Santos.
Yeah. Mhm.
Excuse me, I will record the first presenter in the next the next session. So I tried. Can I try to share my presentation?
Yes. Yes. Absolutely.
Thank you. I tried to my PowerPoint file. Can you see? Can you
Yes.
see my?
Yes.
Okay.
Perfect.
Oh, okay. Okay. Thank you.
You're welcome. Good afternoon, Mr. Santos.
Okay. Good afternoon.
Good afternoon.
Hi there. Just to make sure this is the correct room, we still have 10 minutes to go, right?
Yes. Right.
Okay. So just be here sitting quietly and we'll be back in 10 minutes. Thank you. Anything, just call me.
Okay.
Good afternoon, everyone, but can I test my window sharing?
Good afternoon. Okay.
Okay, thank you.
You're welcome.
Lucia,
Yes.
for the forms, the evaluation forms, are you sending me the link by email?
Okay. Can you send me your email, please?
What is your email?
Can you send me a private message here on Jitsi, and you can write your email, please?
Okay. How do I do that? Yeah, it's okay. I'll take care of it later. Oops, what did I do?
Lucia, I think we are ready. Can we start?
Yes, yes. The floor is
Okay. Okay, folks, good afternoon. My name is Rafael Santos, and I'm going to be the chair of this session at ICCSA. That's the session CSHPC number 2. We have 4 presentations scheduled, and I think most of the presenters are here. So we can just go ahead. Each presentation is going to take, you can take around 10 to 12 minutes, allowing 3 to 5 minutes for questions and answers. So without further ado, I'd like to call Mr. Tomonori Koya to present a paper called Acceleration of Multiple Precision Matrix Multiplication Based on Multi-Component Floating Point Arithmetic using AVX2. Mr. Koya,
Yes, okay.
Okay. Thank you very much. Please go ahead.
Okay, thank you for introducing our presentation. My talk is revised version of our presentation presented in CSSA 2020. That is my abstract of our talk. First, we show our goal and related works, and after that, we explain our targeted multiplication arithmetic accelerated by using AVX2 techniques. And after that, we show the result obtained by our benchmark test of similarity matrix multiplication with AVX2. And after that, we show two kinds of application. One is acceleration of LU decomposition. Another is iterative refinement method based on LU decomposition in Python ecosystem. And after that, we conclude our talk and we show our future works. This is our goal. We are developing a BNC multiple library that supports multiple component type, multiple multiplication arithmetic, including double-double, triple-double, and quadruple-double precision arithmetic. And in our library, we can accelerate a matrix multiplication using Strassen, Winograd, and blocking algorithms. And we want to get better performance. We want to get more performance, so we introduce AVX2 techniques as simmed instruction. So we can accelerate our BNC multiple library. This is our acceleration techniques is based on their Hasegawa, Kotakemori, Nishida, Fujii, and Hishinuma's works. Their techniques can be found in this library. These are our targeted multiple precision arithmetics. One is double-double precision and triple-double precision and quadruple-double precision. So we accelerate these multiple precision arithmetic by using AVX2. AVX2 can be available on x86 64 CPUs such as Intel and AMD CPUs. So AVX2 supports 256-bit width registers. So M256D data type and can include 4 binary precision variables. On these data types, we can use basic arithmetic, addition, subtraction, multiplication, and division. And we can also FMA function. So on these arithmetic and instruction of AVX2, we can simulate error-free transformation, double-double precision, triple-double precision, and quadruple-double precision arithmetic. One of the examples of our simulation. These are error-free transformation used in our multiple precision arithmetic. This error-free transformation can be transformed to simultaneous version of error-free transformation by straightforward transformation. And on this simultaneous error-free transformation, we can build double operation, addition and multiplication like this. This addition, similarities, double operation, addition, and multiplication are the same as techniques in this library. And these are similarities, quadruple operation, addition, and multiplication. These similarities, quadruple operation are also be transformed straightforwardly. But in this arithmetic, ABX2 renown function, this part is completely serial because of complexity in this process. So, but another part can be simulated completely. So, totally simulates the quadruple double addition and multiplication can be faster than non-simulated version. So this is the these are simulates triple double operation arithmetic. This triple double operation arithmetic are based on proposition by Fabiano et al.'s works, but we cannot get faster version of simulates triple double addition due to this merge sort part. So we can use a new triple double addition based on quadruple double operation addition like this. So quadruple double operation addition, this part we suppose these parts are zero. So we can use this simulated quadruple operation addition as triple double addition. So this new triple double addition, we call it triple double addition Q, and can be faster than original simulated triple double addition proposed by Fabiano et al. These two kinds, we use two kinds of benchmark test environment. One is Core i9, and another is EPYC environment. On this computational environment, we can implement simulated error-free double, triple double, and quadruple double operation arithmetic. And we also use new data instruction to store matrix element. For example, for triple double operation matrix, each element have 3 components. So in our new structure of triple double operation matrix, we use binary 46 array, 3 binary 46 arrays to store all elements of triple double operation matrix. So we can use load and store function in AVX2 functions. These are these are algorithms used in our benchmark test. One is block matrix multiplication. In another is Strassen matrix multiplication. This is a result obtained by a benchmark test on serial computation. These tables show the all computational time on Core i9 environment and on EPYC environment. According to these tables, we can understand that simulated Strassen matrix matrix multiplication can be the most most efficient matrix multiplication. So we can better performance than Nakata's Nakata's MP matrix multiplication brass library RGEM function. So we also implemented a parallelized version of our matrix multiplication. The first figure shows the parallel ratio of parallelization with block matrix multiplication, and lower figures show the parallelized ratio with Strassen matrix multiplication. According to these figures, speed-up ratio of Strassen matrix multiplication cannot be accelerated with over 8 parallelization. So, according to these figures, our parallelization of Strassen matrix multiplication have a serious problem. But block matrix multiplication can be faster than parallelized Strassen matrix multiplication. We can also find same performance on EPYC environment. EPYC have 24 core CPU, so the parallelization of Strassen matrix multiplication, the barrier of Strassen matrix multiplication is clearer than Core i9, but on this environment, parallelized blocking matrix multiplication can be faster. So this is application of our library. One is LU decomposition. This table shows the result obtained by using our simultaneous LU decomposition. According to these tables, simultaneous row-wise LU decomposition is the most efficient routine. So we use simultaneous row-wise LU decomposition as default setting. On this LU decomposition, we can implement iterative refinement in Python ecosystem. This list is our implemented Python code to run iterative refinement method combined with MP math library of Python library. By using this code, we can get most efficient result obtained by using triple double precision and MP math library. So we conclude our talk by introducing AVX2 techniques into our library. We can better performance than previous non-simulated version. So as feature works, we want to compare. With Ozaki scheme. So I try to implement Ozaki scheme in our matrix multiplication library. Our talk is ended. Thank you for your attention. Thank you.
Okay. Just a second. Thank you, Mr. Koya. We have time for one question. So if anyone that's watching this presentation have a question, please turn on your microphone, or you can type that on the chat. And if nobody have a question, actually I have one. It's out of
Can I?
curiosity. Sure, go ahead.
Excuse me, can I? Koya-san, could you please explain to me about the why Surasen algorithms cannot be efficient over 8 cores?
Okay. I don't know the reason in detail, but I found that many threads can be run one time in extraction matrix multiplication process. So that is a cause. I think that that is caused by our barrier or parameterization. I think so.
Thank you.
Thank you.
Okay, thank you. In order to try to keep your schedule, I thank again Mr. Koya for the presentation. And I'd like to call either Mr. Isako Kanamori, Kenichi Ishikawa, or Hideo Matsufuro that are going to present the paper Object-Oriented Implementation of Algebraic Multi-Grid Solver for Lattice OCD on SEMD architectures and GPU clusters. So which one is going to present? Mr. Kanamori?
Yes, can you hear me?
Yes. So please go ahead and try to keep the presentation in around 10 minutes, so 10 to 12 minutes, so we have some time for questions. Thank you very much.
Okay. So thank you very much for the introduction. And I'm going to talk about the multi-grid solvers for Lattice QCD application on several architectures. And this talk is based on work with Hideo Matsufuro and Kenichi Ishikawa. Okay. So about target, something's wrong. Sorry. This is the outline page. Okay, so first I will introduce our target application, Lattice QCD. That is a system of clocks. And then I will briefly explain our implementation of algorithms of multi-grid solver. And then I will show you the benchmark result on Intel SIMD architectures and A60 for FX and GPU clusters. Our development policy is that we want efficient implementations on divergent architectures like this with minimum efforts. Okay, so the target application is Lattice QCD. That is QCD is quantum chromodynamics. That is a physics application which describes interaction between quarks. Quarks are elementary particles which makes protons and neutrons. I would say the theory, the formulation of this QCD is well established. But solving this system is another story. We cannot solve it analytically. So then we need some numerical method. And then the way of simulation is also, I would say, established. And then I will not explain the details of the general algorithms, but most time-consuming part of the simulation is to solve a linear system, this linear equation. This D captures interactions between quarks, and then this is a large sparse matrix. Typical size of this D is nowadays more than 10 to the 8th or 10 to the 9th. And then we need to solve this equation a lot of times during the simulations. And then also, as the parameters in this simulated model, simulated system becomes more realistic, then this D becomes more ill-conditioned. That means a simple Kirchhoff solver for the sparse matrix is not very efficient. So then we need a good preconditioner And multi-grid solver is a very powerful method in this situation. So here is a bit more details of the target system. There are several choices of this sparse matrix D. And in this talk, we focus on so-called Clover type of D. And it is a 9-point stencil computation on 4-dimensional spacetime lattice. And this picture depicts the structure. Well, we cannot draw a 4-dimensional lattice. So in this picture, I draw only 2-dimensional lattice. On each lattice size, we have 12 complex numbers. And then in accumulating the information from this lattice to this site X, we need to multiply some complex matrices. And then this is the sketch of the multi-grid solvers. Multi-grid solver itself is not very new, but the application to the QCD is, I would say, rather new. And we start from this original fine grid lattice, and then by preparing a suitable basis that we call null space vector, this I, and then we can restrict this fine grid system to a coarse grid system. This coarse grid system has smaller degrees of freedom, and then we can solve this coarse grid system. Then the solution is prolonged to the original fine grid lattice. And then here, since the coarse grid cannot capture the high frequency mode of the original fine grid system, so then we need to solve the high frequency part by applying another solver called smoother. Then this whole system, whole process is applied as a preconditioner of an iterative solver. And then the quality of this preconditioner is governed by this null space vector, which projects from the original lattice to the coarse grid, the coarser system. And then we adaptively improve this null space vector. This adaptive update is actually the key to apply the QCD. We can make a coarse and coarser grid, in fact, but in our implementation, we start with 2 levels, one fine grid and one coarse grid. And then on the coarse grid, we use BCG stub solver, and on the fine grid, for the smoother, we use a domain decomposed method. We use multiplicative Schwartz alternating procedure. This is the sketch of our code. We use a code base Bridge++. And then the solver algorithm is implemented as a template. The template parameter is the vector field. That is a vector, and we call it a field. This a field itself is templated. And for example, we can specify the precision and the target architecture. And then for each implementation, we prepared optimized linear algebras like AXPy and dot products. The matrix vector multiplication kernel is accessed through the interface class, abstract interface class that we call FOPR. And for our merge grid solver, we need to implement 3 types of kernels accessed through this interface. The first one is the matrix vector multiplication on the fine grid. The second is on the coarse grid. And the third one is a domain decomposed version on the fine grid that is needed in the SAP smoother. This is a sketch of detailed implementation. We have 2 different SIMD architectures. One is by Intel, the other is A64FX. both has in a target 512 bits length, but way of usage are different in our implementation. In the Intel architecture, we pack both real and imaginary parts of the complex number into the same single signal vectors. On the other hand, A64FX, we pack real part and imaginary parts to different signal vectors. It turns out this way of usage is more efficient. We pack also the cases, we pack the set degrees of freedom into the signal variables, but on the Intel case, we use this one-dimensional tiling, and in the A64FX, we use two-dimensional tiling. And on GPU system, we use OpenACC to use the GPU. Okay, this is the benchmark results. And the first one is the Intel system. We use KNL cluster Oak Forest Parks, hosted by University of Tsukuba and University of Tokyo. The left panel is the weak scaling of the matrix vector multiplication kernel. Since we have three different kernels, fine grid, on coarse grid, and the domain decomposed version, we have several benchmark results. And all of them shows very good weak scaling. And the middle panel is the performance itself. If the solid red is for just solving, and this pink one is the overhead to make a null space vector that we call setup stage. And then everything is normalized with solid and this setup. And this blue one is for comparison, the timing from the mixed precision Bayesian subsolvers, where the setup stage takes some overhead, but the solving is faster than this mixed precision solver. The right panel is the strong scaling with some breakdown of the timings. For the ideal scaling, all lines should be horizontal level. And this red one is for the coarse grid solver, yellow is for the smoother, and the blue is prolongation and restrictions. And I would say not ideal, but the scaling is reasonably good. And we use three different test data that's listed here for the benchmarkings. And then next target is A64FX. We use a supercomputer Fugaku. When we submitted the paper, we are still middle of the tuning, so the performance was poor, and then now it's updated, so it gives much better performance, and I would say good performance. The scaling of matrix vector multiplication is good, and the performance is good, and then solver itself is also good, although the overhead for the setup stage is rather big, and we need more tuning for this stage, and the strong scalings are also good. The last example is the GPU cluster. We use Cygnus hosted by University of Tsukuba. That is NVIDIA V100. Unfortunately, the resource we could access was limited, so then the amount of the benchmark we succeeded was not so much. The weak scaling of matrix vector multiplication is okay, and the performance itself is okay, but strong scaling is not very good, unfortunately. And we find that the fraction of restriction and prolongation stage, this blue one, is rather large compared with the other two implementations. Okay, I think it's about times. We have implemented matrix solvers for Lattice QCD on various architectures, and since our implementation is separated from the algorithms, so then we can upgrade our implementation piece by piece to each architectures. And then here is the acknowledgement to resource, grant, data, and code development. That's all. Thank you very much.
Okay, thank you, Mr. Ishikawa. We have time for 1 or 2 questions. You can just talk on the microphone, or you can use the chat for that. Okay, if nobody have a question, I have a quick one, just to be sure that I understand. Can you please go back on the slide that you show the number of nodes and the proportion of time? Before that, this one, yes. Yeah, that one, this one. Is that the fraction of the solvent setup in the elapsed time? But it looks to me that the time for the machine with 192 nodes is very large. Is that
this one?
Yes. Why is that much larger? It looks much larger than.
Okay. So then the system size, the target program size is different.
Okay, so it's not the number of the nodes on the machine. Okay, I understand.
Right.
That makes sense.
Yes, and if I can add some more comments, this set B has a larger condition number, so then it is easier to solve. So overhead is really the overhead.
Okay, now it makes sense. I think I didn't get the explanation of the nodes. So thank you very much. If you have any other questions, please, people, talk or chat or. So if we don't have any questions, I'd like to thank again Mr. Ishikawa for the presentation of his work. And I'd like to call Mr. Takahiro Ino, that's going to present the development of open source-based software planetary atmospheric spectrum calculator, Pascal, specified for millimeter, submillimeter observation of Titan with ALMA. Mr. Ino, okay. Thank you, please go ahead.
Okay, thank you. And can you see my slide? Okay, I confirm that. And thank you for introducing my research title. And I'm Takahiro Ino from the University of Tokyo. I'm going to show you our recent development results of open source based software for the analysis of the astronomical data obtained using ALMA. This photo is of ALMA, and the data is the observation of Titan. Titan is the largest moon of Titan. Largest moon of Saturn. And this is the content I'm going to. I think you cannot see my mouse pointer.
Yes.
Can you see my pointer? I'm circling.
No, we see the pointer, just the arrow.
Oh, okay, thank you. Thank you. And I'm going to show, first of all, I'm going to show you what is the ALMA telescope and its significance on Titan's research, and what is the observation data of ALMA, and show you our recent development results of retrieval analysis code called Pascal, and its results and parallelization attempt and future perspectives. And first of all, I have to say that this is my first presentation of information science conference, and my specialization is not information science, but astronomy and planetary atmospheric science, so that if you will give me good information advices, it will be very good for me. Okay, then I'm going to show you what is the ALMA telescope. ALMA telescope is the world's largest radio telescope, and which is located in the Atacama Highland, Chile. The altitude is very high, as 5,000 meters, and I have not visited yet. And it has 66 high-precision radio telescopes, and they can work as if they are the one big telescope of 20 kilometer diameter. And ALMA is operated by the collaboration of US, Europe, and East Asia, including Japan. The ALMA can observe two kinds of things. One is planetary and interstellar gas, and this is the spatial distribution of HC3N, cyanoacetylene gas, on Titan. And the gas is present both on North Pole and South Pole. This is very, very important and very similar to the presence of ozone on Earth. And the other is low temperature stuff such as dust and rocks. And this is a very close-up view of dust ring and around the young star. Some planets is likely to be present here, but we are focusing on the planetary observation results. And I'm very interested. I'm focusing the research of Titan's atmosphere. Titan is the largest satellite of Saturn's Saturnian system. And its atmospheric composition is very interesting because it is very similar to Earth, which contains nitrogen gas, hydrocarbon gas, and clouds, and even the rainfalls. And its surface is covered with many lakes and possibly with primordial lives. And because of its interestingness, NASA had sent big, large spacecrafts and observed using ALMA. By constraining the Titan's atmospheric environment is very important, and we think it is the most important theme of planetary atmospheric science. And what is observed by ALMA's high capability on the Titan's atmospheric study is here. And this is the schematic diagram of chemical reactions on Titan. And molecules with red circles can be observed by ALMA, like nitrogen, HCN, HNC, and many kind of molecules can be observed, and their spatial distribution can be obtained like this, and the molecules are present only in North Pole or South Pole, and their distribution is very important to constrain their chemistry. In addition, this picture is called FITS format made by NASA, and these files have very large size of 1.5 gigabytes each because this is three-dimensional data. Data that each pixel contains radio spectrum. Radio spectrum like this, x-axis is frequency or wavelength, and y-axis is intensity. And we can see these kind of spike like this or like this. This is called radio spectrum. And by analyzing these spectral shapes, we can obtain the three-dimensional distribution of such gases. And this is previously obtained vertical distribution of such gases. Y-axis is altitude and x-axis is their abundance. The most of gases are present above 100 kilometers or so, and we can find out these two gases, Hc3n and HCN, have different kind of line shapes. And wide line shape indicates these molecules are present in lower altitude. In turn, the narrow line shapes like Hc3n indicates that this narrow line shape indicates the molecule is present only in the upper altitude, so that the determination of line shapes by reproducing this line profile by the very complex calculation with high precision enables us to determine the vertical, because three-dimensional distribution of gases. And because we have so many observation data like this is y-axis is number of observation, and x-axis is year, and blue indicates Titan's observation data. And in each year, typically we have obtained 200 observation data of Titan, so that automated derivation of the three-dimensional distribution of many kinds of gases are very important for the atmospheric study. So that we have to develop the automatic optimization package to obtain the three-dimensional distribution of gases. And previously, many kinds of research have been published, but the main problem is that published results cannot be evaluated by us because each authors developed their own retrieval software. What is retrieval is shown in here, but automatic determination of vertical molecular abundance is called retrieval analysis in atmospheric chemistry science. But most of authors use their own retrieval analysis also that their results cannot be evaluated. So that the combination of open source software is very important, we think. And first of all, we used the planetary spectrum generator developed by NASA. And this can be operated by API and local installation using Docker. And using PSG, and by inputting the vertical distribution of gases, we can calculate the spectrum of each gases. And blue is observed, and red is calculated spectrum by PSG. And by comparing to spectrum, by using chi-square method, and by chi-square method of SciPy, we can iterate this calculation so many times and obtain results. I have just 3 minutes. This is a movie, and left panel is vertical distribution, and automatically optimizing result is red one, and in the right panel we can see the observed spectrum and calculated optimized spectrum in red. Typically by 50 or 60 residuals, we can obtain the optimized vertical distribution of gas. And I have used not so strong machine, but this IO is very fast because we have used the big size of data. By using the Pascal package, we can obtain the we successfully obtain the three-dimensional distribution of HC3N on North Pole, equator, and South Pole. And in this analysis, we successfully obtained that South Pole HC3N gas is 10 times abundant than North Pole. But we have so many data, and about 3,000 data and many kinds of gases, so that we have implemented parallelization method. And we have used multiprocessing method. Multiprocessing is very similar to OpenMP, and we have just 40 CPU cores, and so that this plot shows the parallel speed ups according to the number of processors. Because we have just 40 CPU cores, parallel speed ups does not speed up from 32 cores, but we successfully implemented parallel execution method of Pascal. But parallel speed up is not effective here. This may be due to the disk I/O because we have to read 1.5 gigabytes data in each iteration, and for all of parallelization. Okay, then then this is a summary of my presentation, and the future prospect is here, and we have to batch execute of Pascal for Titan's many kind of gases and so many observation data for many observation epochs by automatically. Okay, then thank you. This is just 15 minutes. And that's it.
Sorry, my microphone was off. Okay, thank you very much for the presentation. If you have any questions, can you people please turn on the microphone or type on the chat? If there are no questions, I always have one. Mr. Ino, just a comment. ICCSA is an international conference on computational science and applications, so any kind of applications is okay with us. So don't worry about your presentation not being information science. We have all kind of science here, as long as I'm computer involved.
Thank you so much.
So one question that I have is that I'm not an astronomer, but I collaborate with several astronomers here in Brazil. And I was wondering if you show that you can use ALMA to investigate accretion disks or formation of planets.
Yes.
So, but which kind of information can we get about the dust? For example, molecular composition. Can we get that through ALMA?
It's a molecular for the protoplanetary disk.
Yes.
Yes, it's a molecular observation of the protoplanetary disk is available, but they are very small, and the molecular abundance is very limited. But people is trying to observe, and people have obtained many kind of gases, which is very same as Titan.
Okay, so it's possible also to use that for dwarf planets in our solar system.
The dwarf planet is very small, and their column density of gases is very small, so that even using ALMA, obtaining the composition is very difficult.
Really hard. Okay, I understand. Thank you for explanation and for the presentation. And if nobody have any other question, I'd like to call the next presenter of this session. That's going to be Mr. Miranda, Matheus Miranda. And several advisors and colleagues are going to present deep convolutional neural network for classifying satellite images with heterogeneous spatial resolutions. Mr. Miranda, please go ahead.
Hello, everybody. Can you see my screen?
Yes.
Okay. Thank you for introducing me, Professor. Hello, everyone. I am Matheus Souza Miranda. I am currently a junior researcher in the master program in Applied Computation at the National Institute for Space Research. Now, I will present deep convolutional neural network for classifying satellite images with heterogeneous spatial resolutions. Thank you for this opportunity. I am really excited for today. Well, the Brazilian Cerrado corresponds to 23% of Brazilian territory and has enriched biodiversity of floristic since the formation of forests, savannas, and fields, and animal species, as the Rofo-Guará, occurring Ribeiro and Volta. However, this biome is threatened by intense human activities, such as agricultural industries, that despite Brazil's food production contributed to the growth of deforestation, where in 2020, there was an increase of 7.3 thousand square kilometers on the Cerrado, as illustrated in the graphic 1. Compared to the last year, approximately more 0.8 square kilometers were registered, according to National Institute for Space Research. Well, these activities are monitored by space research institutions, such as Brazil's National Institute for Space Research, which observe the Earth through satellite images that perform tasks such as classification images about land use and land cover using different strategies, and more recently, deep learning techniques. Among all, convolutional neural networks. With this, we believe that it is interesting to realize whether the convolutional neural networks are suitable to correctly classify satellite images, considering heterogeneous sets of images got by different sensors and different spatial resolution. Hence, the main goal is to evaluate the performance and the binary classification of satellite images with different sensors and spatial resolution by a deep traditional convolutional neural network. Well, all regions of interest, ROI, are located in the Tocantins, identified on the map for the green color, and Goiás and pink color, two Brazilian states where the Cerrado is predominant biome. The ROI1, we selected 21 images with red, green, and blue bands with 8-meter spatial resolution got by the wide panchromatic multispectral camera of the Sibers 4A satellite during the year 2020. In the ROI2, we selected 5 images also with red, green, and blue bands with a spatial resolution of 10 meters by the Sentinel-2 satellite from the year 2018 to 2019. The datasets. We made the composition of each image spectral band of the datasets for training and testing using the TerraView software. To color adjustment and crop about the regions of interest, we used the QG software. In trained dataset formatted by images of the ROI1, we got 1,449 images for the preserved class and 2,607 images for non-preserved class. Given the difference in the amount of the data between the two classes, we implement the static data augmentation method using the tools from Ingalk library. This way, we considered 9 transformations to the first class and 5 to the second class. Thus, we got 13,035 images for each class, as illustrated in the flowchart. Regarding the test dataset, we used images from ROI2. The areas of interest were clipped, totaling 200 images, where 38 corresponded to preserved class and 162 images to no preserved class. The model. We designed a deep convolutional neural network for binary classification with API keras in Python. Looking at the flowchart about the model, we see four convolutional layers activated by the ReLU function, and 4 max pooling 2D and dropout layers. In Fallen, we have 3 fully connected dense layers, each one with 256 neurons, activated by the ReLU function, and 3 dropout layers. The output layer has only 1 neuron, activated by the SIGMOD function, which must classify the image as preserved or no preserved area. Well, this model was optimized with Adam function. The loss function was binary cross entropy. The metric used the binary accuracy. We defined 80 epochs, save the models at the end of each epoch. Accuracy assessment. We use the vector support machine algorithm to give an idea of the characteristics of the image in the test set. Show the band, rate of band by amplitude band graphs. 2 spectral features considering the green and red bands respectively. To evaluate the best model got during the training, we used the predict method of the Keras API. Consider the threshold of 0.98 for classify the image as preserved when the greater than threshold, or no preserved class when lesser than threshold. In order to evaluate the performance of our models, we use the accuracy and F1 score metrics from the scikit-learn library. The results. look at the graphic 2 and 3, we see the results got for each model and your respective score for preserved and non preserved classes, which are presented in the colors blue and orange and the other. Note yet in the graphics 2 and 3 a fluctuation in the classification accuracy in the almost all models, where each model better labeled one of the data sets, of the classes. However, model 49 was the best, according to metrics, where 137 of 162 images were correctly labeled for the non-preserved class, and 37 of 38 images were correctly labeled for the preserved class. Hence, in the graphic 4, we got accuracy in green color of 97% and F1 score in blue color of 98% for the preserved class. While for the non-preserved class, we have accuracy of 84% and F1 score of 91%. In general, in the graphic 5, this model has accuracy of 87%. Well, the classification errors occur more for the non-preserved class, which were confused with the preserved areas. We explain this fact due to higher concentration of dark green tones in certain regions of some non-preserved images, as shown in the first figure. Analyzing the separate higher plan of the test set using the vector support machine algorithm on the graphic 6 and 7, we notice that the classes preserved in blue color and not preserved in pink color are not linearly separable. Take into account radial by amplitude for the green and red bands. And then our model got accuracy of 87%, which were trained in testing with different compositions data sets with respect to image sensor type, spatial resolution, satellite, and studio area. With this, it has a good performance of binary classification. However, for future works, we will design a categorical classification model and use other pre-processing, image, and performance evaluation methods. Given this, certainly the convolutional neural networks and other deep learning techniques for Earth observation help to monitor land use and land cover, make data analysis more agile and accurate. Especially, it's meant investing in ways to make the society more sustainable and ecological. Thank you one more time for this opportunity and for your attention.
Okay. Thank you, Mateus. Folks, if you have any question, you can turn your microphone and ask directly, or you can type that on the chat. And if you don't have any questions, I always have one. Mateus, I noticed that when you train the network, you use a lot of alterations and variations on the image. You flip that, shear that, rotate that. And so you create a lot of sample. Yes, exactly like that. Do you have any idea on the impact of this augmentation on the final result? For example, how would the network, how would the results behave if you didn't do all the variations? You just used the image without transformation?
No, we don't make tests without this transformation. But the one answer for this is to make it the two classes with the same amount of images. And for example, if our network is training with different amount of data for 80 classes, certainly it is classifying more better one the classes. For example, we see that the class no preserve has more data than preserved class. So I think this model was training is without transformation. This model make the classification better for the no-productive class.
Okay, thank you very much. That's one idea for the work is to check how many enlarged or augmentation samples could help, and if there's a limit on that. But it's a gut feeling. We can talk about that later if you want. So, thank you very much for your presentation. Do we have further questions, people? Okay, if we don't have any further questions, I'm going to close the session. I'd like to thank you very much for your collaboration with ICCSA, and hope you enjoy the rest of the conference. There are several different parallel sessions with papers on many areas. So if no further questions or comments, I'd like to thank you very much, and thank you, Lucia. We can finish the session.
Thank you so much.
Thank you.
Thank you very much.
Thank you.
Thank you. Thank you very much. And bye-bye.
Bye.
Siamo... Welcome to the sessions of today, and the first speaker is Marcelo De Palma.
Di Maraj?
De Maraj? Vediamo se è presente.
È lui.
No, Marco Simonetti.
No, eccolo, Marcello è lui. In alto
Okay. And the title of the paper is Motion and Interaction Tracking Tool for Virtual Reality Environments. Please, if you want, you can share your presentation, and the floor is yours.
Can you hear me?
Yes. Yes,
okay.
We can hear you.
Oh, okay. Hello, my name is Marcelo. I am from Federal University of São Paulo, Brazil. Today, I will present the work Motion and Interaction Tracking Tool for Virtual Reality Environments. User behavior analysis evaluates how users move and interact with the virtual reality environment and what obstacles they experience during the navigation, which requires to collect, combine, and analyze user data. Understanding user behavior in virtual environments is fundamental to scaling up these technologies' use and identify correlations and patterns in user movements and interactions. We present an automated tool to gather information about user behavior during virtual reality application use. The collected data can be utilized to improve virtual environments design and to identify points where users have difficulty to perform a task, allowing, for example, an instructor to identify a user difficulties and to investigate the user attitudes. The presented tool logs users' movements and interactions while they are interacting with the virtual environment. The data are combined and charts are generated automatically. Moreover, these tools allow the researcher or user to replay user behavior in virtual environment. Furthermore, via such replay, it is possible to recreate in detail the user's playing experience. We also present a case study which a user navigates and interacts in a virtual reality city, simulating, for example, a patient during a physical therapy session. To facilitate the software development process, we developed a Unity asset, allowing developers to use the tool easily by importing our asset into their projects. Although the idea of automatically tracking what users are doing while interacting with the environment seems simple, this task is complicated regarding virtual reality applications that use non-conventional devices, where the quantity of movement and interaction is immense. Our tool is integrated with the game engine Unity in that it was not originally designed to grab information about user behavior. The tool was designed to be easy to use without writing code. To use our solution, it is necessary to create the hotspots with colliders that allows to record users' movements and interactions. The developer should also add the tracking tool script to the main camera. So first, the developer creates the application and adds the tracking tool script and to the main camera and the hotspots. When the application is running, the log files are recorded. We register data about the user camera, hotspots names, timestamp, and interaction with the environment while the application is running. Then charts are generated and the application can be replayed according to data registered in the log files. We use quick chart services to generate chart images on the fly. Charts are rendered by chart.js on the web browser. This solution allows all the users' activities to be described regarding chronological order and duration, allowing a better understanding because of the visual metaphor employed. We defined as a use case the activities of a user interaction with city artifacts. The user interacts with streets, sidewalks, and crosswalks. We simulated a 3D city that is present in the figure in the left, in this figure. The hotspot created to track the user behavior are present on the figure on the right. Here, we have some hotspots. We are interested if the user utilizes the pedestrian crossing properly when navigating to some place such as the gas station or bus stop. This figure shows the hotspots created in the chosen 3D city. The colliders of each hotspot are enabled and set as the trigger. Then the hotspots detect external interaction from the user's camera and execute specific code. Then the application can monitor when users collide or stop touching a hotspot. We gave to our user the task of going to a variety store and returning to the start point. So he should go from here until here, the variety store. He had to cross 2 walks to go. He can go in this way or this way, and to crosswalk to return. He had unlimited time to accomplish the task. Once all the data were recorded, we transformed it and analyzed and interpreted the results. All charts were created automatically. The left chart shows that the user spent 93 seconds to finish the experience, and the chart on the right shows that he performed the task 1 time. This figure shows users' route during navigation, represented by a graph. Each node is a hotspot, so we have the hotspots here. And the edge label shows how long the user took to move from one hotspot to another. For example, the user spent 24 seconds from the crosswalker until the gas station. This chart shows how many times the user traveled between the 2 hotspots. So he starts here and go to the crosswalk 1, after he went to the crosswalk 2, after he went to the gas station, the variety store, and returned to crosswalk 2, the crosswalk 1, and finished the experience. This chart shows how long the user stayed inside the hotspot area during each crossing. For example, the user spent 6 seconds walking the pedestrian cross 01 in the first time, and 2 seconds in the second time here. So he crossed the crosswalk 01 2 times. In the first, he spent 6 seconds, and the second moment he spent 2 seconds to cross. After walking in the 3D city, he had the opportunity to replay users' movements and interactions, including the gazing behavior that can reflect the user's attention to special objects. From the observed results, the performance of the application was not affected by the tracking tool, being able to maintain the user experience in real time. User behavior analysis is commonly employed to identify patterns related to individuals when they are using applications. Understanding user behavior in a virtual reality environment is not intuitive and depends on various factors, such as interaction and visualization device usage and the word complexity. This paper presented a tool that gathers information about users' behavior. This tool, integrated with virtual reality environments, track users' behavior, allowing structures, designers, developers, and researchers to reduce errors and save significant time. From the observed results, we concluded that our tracking tool has achieved its purpose, allow us to gather information easily about user while they are navigating and interacting with a virtual world environment. As future work, we intend to use our tool in specific contexts, such as in the motor rehabilitation sessions. We also aim to add new charts, such as a heat map. It's that. Thank you.
Thank you for your presentation. And let's see if there are some questions. Okay, no questions. Do you record the timestamp during the user's activity in the environment, or not?
Yes, we record everything, like the timestamp, his position, and where he's looking for, so we can replay all the movements and everything in the environment.
Very nice.
And
okay, the next paper is Augmented Reality in Medical Education, an Empirical Study. And the author, the presenter, is Zsigmond Imre. Please, if you want, you can share your screen.
Hello, I'm Alexander Buhai. I'm gonna present this for us, but okay. Imre is in the call as well.
Okay, perfect.
I'm gonna share my screen. Let me know if you can see it right now.
Yes.
Can you see it?
Yes, we can see it.
So first of all, thank you for having us here. It's an honor, and the other presentations from today were all great. I'm going to present today the Augmented Reality in Medical Education, an empirical study. What's the problem? Why do we choose to do this? So nowadays we have access to high-end medical learning devices, but as we live in a third world country, the cost associated to this kind of devices is really high, and it's not accessible to the university hospitals. So the idea was to try and use the latest augmented reality technologies and the current devices to help the students learn and visualize new pathologies in real time, while also trying to make them interact with each other. And later, we even added some gamification techniques. The realization was that such a solution is nowadays possible. And we started this in 2018, and now it's really possible with the current hardware, smartphones, software options, and the image processing algorithms that have gotten really good over time. We tried to find an inexpensive solution that is already present in the students' pockets and for the teachers as well. So we started creating a mobile application and a desktop application that detects a person's face and tries to overlap realistic skin conditions on top of it. Augmented reality is not something new. It's actually been present from 1968, and it refers to technologies that project CGI over the real world A good definition from Ronald Azuma was that it should have three characteristics. It should combine the real and the virtual. It should be interactive in real time, and it should be registered in 3 dimensions. It's a variation of VR from the previous presentation. And while the user is not fully immersed in the virtual environment, he can interact with the objects and the superimposed objects in the real world. Nowadays, it's regained public attention because of the development of smartphones and even newer the glasses, the smart glasses. This is Microsoft HoloLens and is being used in teaching to project and make holographic projections. For image processing part, we used Open Computer Vision, and we use this together with the Unity 3D game engine. And we used the HAR cascade and AdaBoost classifiers in order to have a fast solution for finding someone's face. This is really important because, as we said at the beginning, we were interested in using the students' phones that may or not may be low end, and therefore we needed something really fast and good enough for us to find the position and the orientation of a human face. Also, I just tested this today as an off topic. It works with masks as well. About the Unity 3D engine, it's really quickly is a cross-platform game engine. It uses C# programming language, and as the previous speaker told us, it even has an asset store when you can quickly extend the basic functionalities. This is basically the interface of it. You can see in the bottom the materials and the textures, and even though we don't have like a 3D special team, we managed to pull them together in little time. These are the diseases for now. It's just a proof of concept, so we added 3 diseases with multiple position. It's antelasma, herpes, and melanoma. They are all basic diseases that are being taught in the 3rd and 2nd year for the medical students. So we tried to do a study. Unfortunately, the sample size is quite low, but it shows that there is progress. We just explain the students the concept and then let them use them both on themselves and on their peers for 5 to 10 minutes. All the users were 3rd year medical students. Also, because how I said before, the diseases were thought to be recognizable, it may or not have not influenced the study. These responses were all positive of the study, but the statistical significance is not warranted yet, and further studies are needed. But a good thing was the discrepancy between the first 2 questions, because that shows us that in the medical textbooks, sometimes the pictures are not that accurate or not that comparable to real life because of lighting or 3D effects, and it was better with the app. So conclusion and further work. The purpose of the article was to see if a low price and easily available educational real AR application is possible. And we showed that with a proof of concept that I'm going to show you in a bit. It was. We consider the result a success for now, and some further work is needed both with the study and also with expanding the sample size, both of the diseases, and maybe even try to expand it furthermore to detect hands or other parts of the body. Let me start the demo. I'm gonna screencast my phone. If it's not working, I'm gonna start it on the website. Can you see the screen?
Yes, we can see it.
Let me check if everything is fine. I'm gonna start the face tracker and switch the camera. It works with both. So at first, it just as you can see, it represents an illustration of the disease on my face. It works with beards as well, or other facial features, and you have three choices of it, and it's made to be like a game show. I don't know if you can hear it. Let me just pull it, and let me just so. Something is not okay with this. So this is herpes. I don't know if you can hear that, but it's using sounds to make it better for the students.
We see you, but we cannot. We can.
So it uses like wannabe millionaire sounds.
We cannot listen the sound because the sound is not propagated.
Yeah, yeah, I thought so.
Okay.
And you can also see the face tracking as well, and how the virtual head is being seen right now. And for gamification purposes, we have a leaderboard. We could later implement some kind of timers and level ups and make it more competitive for the students, because in the study they were really positive and having it more competitive. So this is pretty much it. I went through it a bit faster than I thought. But let me know if you have any questions or any parts where you want me to add more.
Okay, we have just one question. And do you think to improve your work, expanding the set of diseases that you can represent on the face? And my second question is, I think that you should try your app on a bigger data, on a bigger sample of peoples, because I think that 9 peoples are too few.
Yeah.
And okay, because I think if you increase the number of people that will try your application, I think that you will get some more feedback and you will be able to improve your application. Okay.
Do you have any information regarding the user experience? So the students express their feeling about the app?
From the studies, they were all likely to recommend it, and they were actually stunned that it works so well on their phones. But as you said, the nine students is not that much, and we need to like collaborate with a medical faculty in order to increase our sample size by some margin.
Okay, thank you so much.
Thank you as well. And related to the sample size of the diseases, yes, we chose those because they are really identifiable and they could be mapped in position with facial features. So, for example, Santelasma only appears around the eyes and herpes around the mucous surfaces. But more, we try to have lupus as well, and like from anything from dermatology is kind of is easy to represent. Also, even more, to add, we had the scoreboards, and if you get the response right, you get 10 points, and if you were wrong, you were subtracting 5 points. And some students actually asked us that they wanted to have combos and like some better visual feedback for their answers. So those are in the further work as well.
Okay, I have just one more question, please.
Yeah, sure.
Do you use the spawn points for spawn the diseases on the face?
We had
the unity spawn points.
No, we don't. We have some game objects in different places around the face that could take the texture
Okay.
of the disease, and is also like it has light effects and tilt effects.
Okay. Thank you.
Thank you as well.
The next paper is evaluation methods applied to virtual reality education application, a systematic review, and the first author is Daniel Bueno Dominguetti.
But I and the third author, Marcel, I will present the paper.
Okay, please. If you want, you can share the presentation and start.
Okay, can you see?
Yes.
Yes. Well, my name is Marcelo. I am from Federal University of São Paulo, Brazil. I will present the work Evaluation Methods Applied to Virtual Reality Education Applications, a systematic review. Evaluation is a crucial stage in software development, being considered in various methodologies and development processes. It allows us to assess the product value and quality. It can be executed based on different perspectives. In case of software engineer, it aims to verify whether the software meets its specification. In case of human-computer interaction, it evaluates the user experience and design alternatives. In general, evaluate a software is not a trivial task. In case of virtual reality applications that use non-conventional interaction and visualization devices, more challenges appear. Virtual reality applications require specialized research to execute the evaluation and special concerns on how to define the tasks properly. This paper aims to present a systematic review to understand how educational applications based on virtual reality are being evaluated. Here we have the research question. The first one, what are the most popular methods used to evaluate educational software based on virtual reality? The second, how the methods that had been used in researches were conceived. Research question 3, what are the most popular data collection tools that have been used? Research question 4, how the data collection tools were conceived. And 5, what is the most common research approach which has been used by the authors? Considering terms from virtual reality, evaluation, and education, we build the following search string. So this one. We consider studies published between 2014 and June 2020. And the ACM digital library was used for the analysis. All papers returned by the search string were considered. The criteria were applied initially in the abstract of each paper. If it fulfills the selection criteria, then the whole paper was thoroughly analyzed. We considered the following inclusion criteria: studies that have developed a virtual reality application considering education as the main objective, and studies that have been peer-reviewed. Studies that fulfill at least one of the following criteria were excluded: studies related to education, but that has not developed a virtual reality application; studies that developed a virtual reality application which is not related to education; studies that had an evaluation which is not related to education or virtual reality; and great literature, for example, resumed articles, posters, theses, and others. 1,351 papers were retrieved from our search string, in which 23 were eliminated due to the lack of access. 1,247 papers were rejected, and only 81 were accepted according to our selection criteria. We note that the number of papers published increased through the years. We can see here. From 81 papers selected, 6 were published in magazines or journals, and 75 were published in conferences. Only 3 papers used a validated method to conduct the evaluation. 38 papers adopted other methods or have similarities with the classical ones. Commonly, they implemented human-computer interface principles. 18 created the method in their way. 59 papers implemented an evaluation, only 2 not with users. About the evaluation process, 38 papers opted for a quantitative approach, 8 papers opted for a qualitative approach, and 13 papers used a combined approach, quantitative and qualitative. About the tools adopted, 26 papers used just one tool, and 33 papers used more than one tool. Well, research question 1 was interested in the most popular evaluation methods. Most of the evaluations were based on methods adapted from the human-computer interface area or created by the researcher. The lack of a well-defined experimentation structure can lead to problems regarding data validation. Despite the reasons and importance regarding the experimentation design, only one study has formally used them. Research question 2 was interested in how the evaluation methods were created. The typical approach is to adapt some method or create its own. So this lack of use of a well-defined method creates barriers to generalize the evaluation process. Research question 3, we're looking for the most popular data collection tools. Again, there is no specific instrument. The authors prefer to use common tools, that is, tools used to evaluate any application such as usability, technology acceptance, and presence questionnaires. And research question 4, we're looking for how the data are collected. Most of the studies use one instrument created by their own research to collect the data. This approach brings difficulties to be sure about the variables and interpretations. And finally, the research question 5 is interested in the research approach. Considering the 59 papers which performed an evaluation process, we found a quantitative, qualitative, and combinative evaluation. 38 papers used a quantitative evaluation, 8 papers implemented a qualitative evaluation, and 13 papers combined qualitative and quantitative approach. Well, the virtual reality definition about the threads to validate this research. The virtual reality definition was a problem in this study. We eliminated studies that have no used a specific virtual reality interface. Well, there is a lack of concrete definition to assess what is and what is not virtual reality. Also, we used only one research source in our systematic review. The use of more sources would provide us a broader understanding. And another thread is just one person extracted the results, which were not validated with another person to validate the studies to find different assumptions and results. Concluding, considering virtual reality applications which use non-conventional device, for example, head-mounted display and data globes, the evaluation process is more complex than in common applications like web applications. We executed a systematic review considering the last 6 years, and most studies conducted were based on the adapted methods, and it's common to use the evaluation tools from human-computer interface area. There is a lack of specific theories to evaluate educational virtual reality applications. This lack affects the data integrity, analysis, and ultimately the study reliability. As future work, we propose to expand this research exploring other fields, such as virtual reality in the health, and analyzing other specific repositories. That's it. Thank you.
Thank you for your presentation. Let's see if there are some questions.
Marcelo, do you think that how can be overcome the lack of standard and support instrument for making this type of evaluation?
Sorry, Oswald, I can't hear you well. Could you repeat?
How do you think, who essentially, there is an organization that can overcome the lack of standard or instruments to make possible this type of evaluation, to make this evaluation more straightforward, more let's say standard?
Oswald, it's a hard question because I think that virtual reality is a new area, so it's hard to. I think that we are not mature enough yet. So we are trying to build these instruments yet, and I think that a good way is really import the instruments from the other areas, like human-computer interface, but they are not. They can't cover all our requirements. We have to adapt, and then you have to. This area needs more research yet to establish instruments.
Thank you so much.
Thank you.
Thank you. The last presentation is IoT to monitor people flow in area of public interest. The first author is Damiano Perri, and the presenter is Marco Simonetti. Marco, if you want, you can share your screen and start the presentation. We cannot hear you. Please check your microphone. Okay, your volume is very low.
Okay. It's okay now?
Yes, it's okay.
Perfect. Okay, I can start.
Yes. Okay, we can see your screen share.
Is it okay? Can you see my first slide?
Not yet. Yes.
Oh,
We
okay,
can,
perfect. Well, my name is Marco Simonetti. I'm at University of Florence, but I have an affiliation with the University of Perugia as well. I'm here to introduce to IoT to monitor people flow in areas of public interest. And the aim of this research was to set up a system to monitor the flow of people inside public places and facilities of interest such as museums, theaters, cinemas, and so on. And all this without collecting personal or sensitive data. Here we can see, you can see the structure of the presentation. We have an introduction, description of the system, and conclusions. The words Internet of Things refer to a collection of objects that gain intelligence through the Internet, exchanging data about themselves and gaining access to information from other sources. What do we mean when we say the word flow? Flow is a set of homogeneous elements. In the case of a project, we intend the natural person, the person itself, of which we, in this first phase, want to measure the quantity inside our environment. The areas of public interest are infrastructures, and there can be public or private within which of the flow passes through. Well, to ensure the generic collection of data useful to grant service and to realize the anonymity of individual people, we thought of a scalable stack architecture as shown in figure. And this architecture has been chosen in this way. We get it divided into 3 logical levels: data acquisition layer, coordination layer, presentation layer. We have data acquisition at the bottom, and the presentation layer is at the top of the stack. So the coordinators process this information within the activity and then send it to the servers, all these. This will be achieved with storing the data and transforming it into information. And this information can be used by the end user. And this data can be presented to him or her by an app. Description, we can now pass to on the description of data acquisition layer. This layer contains every object related to the collection and conversion of sensor data, and convert it into processable information from higher layers. The sensor that we have chosen is a very common sensor, and it works in a similar way to those of thermal scanners. The sensor is a matrix sensor composed by lasers as well. And as we said, it works as thermal scanners once. And they project to the ground an area from which the temperatures are measured. And the microcontroller we have chosen is the ASP32 type, and he can read this information and extract the information on the flow through specific algorithms. The sensor's output signal is a low-resolution thermal picture, and it is related with a lot of noise. This noise must be, can be reduced, and we did that by using interpolation techniques and filtering matrices. The interpolation technique utilized by us is bicubic interpolation, and the filtering matrix was created using a technique called background subtraction. Only when the noise has been attenuated, we worked on the instrument's sensitivity that we have modified using a threshold value, as in picture. This procedure gives us the possibility to hold the highest values of the matrix, to decrease or attenuate the minimums, and to identify the individual clusters. In this picture, we can see two clusters in the specific, and cluster are some matrices of variable shape and size, which represent the area on which the person is projected. So this cluster represent persons that are going through the door. After that, we have a new layer, and it's the data coordination layer. And we find all the devices that deal in this layer, that deal with coordinating information that arrive from the flow meters that are sensors. They are divided into two types in the specific: internal to the infrastructure and external to the infrastructure. The former are microcontrollers that we can say manage the synchronization of data that arrive from different types of sensors. And the latter are servers that communicate with the former through the MQTT protocol and ensure the consistency of infrastructure acquisitions. In the picture, we can see a schema on it. The coordinator is in charge of handling a number of acquisition devices. Their responsibility is to manage such data in accordance with the requirements of the linked devices, and to act as spokesman for a summary of them with the MQTT broker. Our infrastructure must be a closed system in order for the broker to be aware of the full flow. We can say that this enables the broker to ensure that the incoming data is consistent and to store it in a database. The broker and the coordinator use the MQTT protocol to interact in a safe way and reliably, and they take particular action based on the messages they receive. Here we are, the presentation layer, and this level's goal is to make the information saved by the user available through the device situated at the underlying levels, as well as to control the access mode for single users, ensuring the separation of duties for any of them. As a result, the primary activities for this layer are as follows. They have to make the information acquired by the devices located at the underlying levels available to the user, as we said. They have to manage access methods, and they have to separate the responsibility relating to the user profile. The structure of this level has been properly tested in a variety of environments. We can say there is a Docker container that virtualizes the data archived in the MySQL database. And we have a server too, which runs on a virtual machine and exposes only the endpoints of the API that the application calls. The presentation system consists of three components: the database, the web server, and the client. And the infrastructure services control primary database operation using API that are available to the application client. These API are divided into three categories: authentication, test management, and device management, each of which corresponds to a separate set of database items. In order to manage an activity, we can say that it is necessary to be registered previously in the system. Each time the user wants to perform an action, a request is sent to the server. This request is successful only if the formal check is correct. Once the user has been authenticated and authorized, she can proceed with the management of her company profiles. In order to use the advanced features of the application, the user must be registered and enabled. And here in the picture, we have an example of an authentication form. The program has also been enhanced with a new module that allows visitors to get information on artifacts as needed. We intend museums, exhibitions, and so on. The user may take a guided tour of the facility and examine the key pieces of art using virtual reality methods. Furthermore, inside the structure, a sequence of QR codes have been developed that allow the viewer to see the artifact using augmented reality technology. On 42 average daily passes, we detected a result of 0 for 8 days, a value of 1 for 4 days, and a value of 2 for the remaining 3 days. That seems to indicate us that our system has a high basic detection capacity. The Internet of Things offers virtually infinite tools and possibilities. I mean, both in terms of prospects and future extensions, ranging from the establishment of a basic information process to the installation of a true portal capable of allowing business owners to connect with interested consumers. I wish to thank you for your attention.
Okay, so
we can close the session.
Yeah, we can.
Okay, thank you very much.
Thank you all.
Thank you.
Bye.
Thank you
Bye
for
to everybody.
Bye bye.
Bye to everybody.
Bye.